Thinking back to the equilibrium module of this course, whenever we discuss an equilibrium reaction, we need to keep in mind both Q and K. So when we have the beaker filled with water, and we are going to dissolve lead chloride into this beaker, we know from the previous video that lead chloride is only slightly soluble in water, and only a small amount of lead ion and chloride ion are going to form in this beaker. So to write the equilibrium reaction, we're going to write PbCl2 solid dissolves into lead ion into chloride ions. And if we want to write our equilibrium expression for this reaction, it is the concentration of lead times the concentration of Cl minus squared. And remember, this is the solubility product constant, Ksp, which will tell us the concentration at equilibrium. For both of these ions. So Ksp will tell us the equilibrium concentration for lead and the equilibrium concentration for chloride when this solid is dissolved into this beaker of water and it has reached a point where it has dissolved enough lead and enough chloride where it has now reached equilibrium. However, we know from the equilibrium module that not every reaction is at equilibrium. So when this lead chloride is first dropped into this beaker of water and it has not had any time yet to dissolve either lead or chloride, this reaction will not be at equilibrium. It will not have dissolved enough lead or chloride to get to a point where it is the equilibrium concentration of those two ions. So what we can do for when we are not at equilibrium is we could write an expression for Q. Q tells us about the reaction at this given moment in time, not at equilibrium. It is more of a snapshot of what is going on in this given moment. So K tells us about the equilibrium concentration of lead and chloride. However, what happens when lead chloride dissolved in water is not at equilibrium yet? There is still more ions to be made. So it is the same situation. However, this beaker will describe the reaction when it is not reached equilibrium at this given moment. So what we will do is we will write QSP, which is still products over reactants. It is the solubility product, but it is for Q, which tells us about right now, not equilibrium. So it is still going to be concentration of lead times the concentration of Cl minus squared. However, we know that for this beaker, this QSP expression is going to tell us the product of our lead ion and our chloride ion at a point in the reaction where it has not reached equilibrium yet. So distinguishing between QSP and KSP is going to be really important when we go to solve a solubility type question using an ice table.